Let's continue solving questions on Bellman. So this was a direct question. What I've realized that in interview or wherever board is applied, not be what you can say evident that we can apply Bellman-Ford in this particular problem. And I have seen many questions. So I'm taking one such question where there is no negative, edge weight is given, even though applying Bellman-Ford is one of the best solution of that particular question. So let's take this one, for example, where we have some cities here naming 0, 1, 2, 3. And we are given with a list of flights that from 0 to 100 or 2 we can go in 600. So likewise, cities and a flight list is given. And our target is to find out what is the cheapest cost or price we have to pay to reach from a source to a given destination. The only list here is that you only can have in between. If this is a transition flight, then you should not have 2 stops is where Bellman-Ford will help us. Let's see to the graph. Let's take the simple example. So imagine we are having a graph where from city 1 we can reach in 50 cost, 2 to 1 in 10, and 1 to in anything, say 20. There's only one route, right? And our target 0, 3. Find the cheapest possible way to reach there in at most 2 stops. Okay. So if I try to do it first, if you have seen the series we are discussing here, and when you are doing this question in the interview, first thing you should, there is a weight on the edge. That means direct breadth first search you will not be able to do. That much we should have established by now. Okay. Next is if here there is a weight and a positive weight is given and minimum cost is asked, then you may think in direction of that I can apply something like Dijkstra where I will use, but here is a twist. So what will happen is if you are applying breadth first search with priority queue, so your source is by default your source is 0, and let's suppose you are maintaining a distance array, then in that for 0 it will cost, but from 0 you will be able to reach in 50. Means when I'm expanding how we go, right? 1 we can 50, 0 to 2 I can go in 10, and 3 is still infinite. Then if I pop out 10 from the priority queue, because this is a next lower 0 is already popped out, then I will update 1 that reach in 10, hence total cost to reach to 1 will be 20 plus this 10. There it is wrong. So if I'm having a k given 2, this is correct, that my k is still not 2. I may end up updating this one, update it with the wrong answer, because from here onward then I will not be able to continue. So though I can maintain distance separately at every node, and I will think that 20 but stop 1, when I'm coming from here 0 so far and cost is 50, so I should continue, but writing that code will not be very clean. Risky that it's possible that we ultimately will reach to a phase where there will be an error. We can say maintaining it, I may discard the route of 0, 1 directly, and I'll continue with 0 to 2, 2 to 1, because that is giving me a better cost so far. We will go ahead and pop out 1. If I'm applying direct Dijkstra algorithm, which is priority with breadth first search with priority queue, right? Where for when k is limited, this route to not be correct one. And what we're concluding very early into our algorithm, that going via 0 to 2, 2 to 1, we are applying Dijkstra directly. So that is where intuition is what happens when we do Bellman-Ford. If we just try to establish that in ways from 0 to, then we have 3 from here. Right? So what we do in Bellman-Ford is, in our dist, first we check that in my first answer for all the nodes, because I process every edge. At source it is always 0, so I'll check for my 10, because that was the cost of at the edge. For this one, the best answer so far is, let me redraw it here. So dist is equals to, for source 0 is 50, and for second 10. For third, I do not have an answer yet, so it is still infinite. In second iteration, I will do is again every edge, but where I already know one when I process this one, so I'll get a new for 1, and that be also telling me that, because that new answer will be that I'm running it with second time, which means now I already explored one stop mode looking for the second answer. That means one route answer it have already got, and when I will do another processing, there will be a new answer. So for 0, nothing will change. For 51, with the answer, am I allowed to do that one stop or not, is something I need to check. So if equals to 2, that is where okay. But if my k is equal, in that this is my intermediary node, hence I will not be able, equals to 1 is given, so I cannot this one, so I'll keep it as it is 50. So what do we do in Bellman-Ford? We say that when I'm doing one for every edge, right, that means I am checking that to reach to that destination, like in case 3, from source I have processed v minus 1 routes. Edges are included in the answer, and here in this question allowed we are given a k, that means vertex, these many was k vertex, how many edge allowed to me. So from source 1 stop 2 stop, that means there will be 3 edges. All right, process every edge k plus 1 times, that means I am stopping k times, and that is what my answer will be if I simply run Bellman-Ford here. Let's see how. So if the in my graph, if this was the graph with 10 10 50, and till from here it will 10, by default my distance will be 0 infinity infinity infinity, right? Then I'm saying in my first iteration I got 0, it is neighbors. So in both the neighbors, process edges. First edge I will process is 0. So this one was, we say, oh, can I bet my dist here for the source? So I'll simply add the value and we'll call it 50. Now for this as edge 0 to 2, now the cost is 20. These two, nothing else is happening. So now, because if k1 is given, so you will do iteration 2 times. In my next iteration, what I'm going to do is, now I will edge, which is, you can say this one. I'm only, obviously I process every edge, right? But it will make any sense because earlier there was infinity here, so not getting we will simply skip it because of the if condition we had. Okay, let me erase this one. Okay, go back. So now if I process this edge now, what I will get is from now I'm talking about iteration that for 2 to 1. So first if I process this one, which is 1 to 3, this edge, then what I will get, 1 is having 50. So here I will be able to say that 60 right now is 60 with one stop. For 1 the answer will be updated to 20 and 0 will be as it is, and for 2 nothing will change because there is no new edge onto 2, so nothing changes. This will happen when we process. This was the first time. When I processed it like this, then I'm not going to process it one more time because k was 1, so hence I can only do these number of processing 2 times. From here now I will simply return what is the answer for destination, and if this is still infinite, that means I cannot there in these many stops. I think the only change I'm doing here is if I will update directly anything into the dist, then obviously it's possible that I would have updated my this to 20 in the array and this value would become 30. That would have been a wrong answer because right now I'm talking about second iteration. That means only 2 when only one stop is allowed, and at that time this is not the right answer. So what we do is checking the value in the in previous step what was the dist value, and then only we are updating the of this current index. So so what to do is we should keep the previous iteration some temp array and use it from there correct for the current iteration, and that will be the only change Bellman-Ford algorithm which we did. I'll copy it here from here, I'll paste it here. This now I can safely change to here. I don't need to check the negative cycle are given in this question, so that check I can safely remove. And one more thing I said is that what we passed to me, that I don't need to run number of vertex time, but there will be an extra parameter called k, and I should run it k+1 times like we saw, right? Have my answer in my dist array. Another thing which okay, yeah, changes if we are value for the dist current, then it's possible that it will give me wrong answers. Only thing I should change here is that I copy from previous iteration. Yeah, so when I the iteration, I will say in my temporary the array. So the way to copy all the values of an array into another array in Python. So whatever having it here, this is important for only for this question, that value what was there in previous one, and not modifying the same when we are processing the current iteration. Otherwise it wrong answer like we saw in the. Now when I copied, simply checking is if this is still, so check right now because I will update it with the minimum value. So I'll say if my source is of this particular edge, if value is not infinite, so I'll put it into temporary, will be minimum of whatever is temporary v right now. So that is why I'm not checking whether this value is better or not, because this is where we are either keep the value as it is or we'll replace it with the better value. Minimum of whatever is there in the temporary v, or now add distance of u, whatever was the cost to reach till plus means source and the weightage of that particular edge. And in the end, once you processed edges, then what now my dist is equals to TMP. Now you can simply put all the values here. Yeah. So after first iteration, I will have 0 and all are in 0 plus whatever direct edges I am having, like 0 to 1 it is 100, so at 2 it will be 500. And then if k is still 0, okay, there will not be any next iteration, will run only one time. But in case of which we saw earlier, there like this one, 0 to 1 it updated in first iteration and nothing else will be processed. Then because k is 1, so loop will run 2 times. So 0 to 2 we will update to 200, but 1 will be 700. And here, if any edge, yeah, there is actually an edge between 2 to 3, but it will not consider it because into temp array, but update our code on this basis. So what we are doing is, from here I'm calling my self.Bellman-Ford, where I'm passing what is the number is flights, n is actually should be cities, yeah, n cities. So 0 to these are my number of vertices, I can safely say. Flights is nothing but the edge is me, and I have a source, so source I can pass directly as it is, and k is another parameter which I'm using. So this should give me a desert, and if destination is equals to infinity, which is, let me define again. If this is still infinity, that means I cannot reach to the destination, and I will say -1 as asked in the question. Otherwise, I should simply return whatever is the cost here. Let me just run if there is any compilation error. Okay, so all the basic tests, let me submit this one. Cool, it's working. So I know it is not easy to see that how Bellman-Ford could have fit into a question like this, and share a kind of a pep talk and short story. I recently took an interview of one candidate from IIT who is currently working in one of the big four. He's an experienced guy, experience in big four. Asked him a very similar question to this, or you can say this question only. Dijkstra is, he knew what Bellman-Ford did, but when I given him, he was not able to think this answer directly. He could not think of BFS plus priority queue, which is Dijkstra, in the first place. Reason behind it, he did not read it from this comparing breadth first search when all the edges are having equal weight or no weight. And when there is a weight of different weightage on the edges, then I should not apply this. He thought direct BFS is working here. It's just that he need till kth. When I pressed a little more, then he was able to check it. He knew all the algorithms on top of his mind. He again made the similar mistake which I was trying to explain in the previous step, that if you are maintaining the dist array, simply in your Dijkstra, it may conclude whether of that for that particular node, that 200 best weight here, which is correct. It will consider this 200 here. You may say that cost is 400 to reach, because you concluded early. Or the better comparison is the graph which we saw earlier. So that was though this is not the inspiration for me to record this series. I was anyway recording it, but that gave me a clear indication that if we do not do this study like comparatively like this, that where algorithm and then where this algorithm, then it is easy to identify. He was a very good candidate who knew all struggled, and that was a mid, like you say, the medium question. This is not even hard yet. This very helpful for us to pick in first 2-3 minutes. When we got the question, we will be able to discard some of the basic algorithm that we if I need to run an algorithm with edges, right? A some k constraint is given, then Bellman-Ford can help me, because that is how it expands edge by edge. It includes for every given target, like 2 in this case. First, it will check for in first iteration that from in how much cost I will be able to reach, which is infinite, right? Because you do not even have answer for one. In may also include 0 to 1 and 1 to 2. This is second iteration. So for every node, previous 2 bursts of that particular vertex, know that will to identify that algorithm very early into the view, and we will be able to do very good in if we are practicing it like this way. That's it, I think, about this question. Time complexity wise, there's nothing changed. It is still same what we were doing in Bellman-Ford. The only extra thing we are doing here is copying that entire array into an temp array. I think I will leave it to you to see what is the effect on time complexity when we are adding this line. And yes, this is acceptable because we were able to do it for the given constraint. Yeah. Thank you very much. See you in the next one.